Alright, so we'll get going here on number 5. So we're basically we want to see if this thing is on the unit circle. Well, we have an equation for the unit circle, and that equation is x squared plus y squared equals 1, right? I mean, this thing is a circle, and it is 1 unit in every direction, so the radius is just 1. So our equation is just x squared plus y squared equals 1. So we're wanting to check if this point is on the unit circle. So we can really just plug this point into that equation and then double check to make sure that everything works out. And if it does, then the point is on the unit circle. And if it doesn't, well then it's not. So we're just going through here and we're plugging everything in to the unit circle formula, or the equation for the unit circle. So we're wanting to check, see if that's true. So we go ahead and we distribute that squared in. 3 squared is 9, 4 squared is 16. Distribute the other squared in. Negative square root of 7 squared gets rid of that negative and the square root, so it just becomes 7. If you add those together, we get 16 over 16, which equals 1. So everything adds up once we plug it into our equation, meaning this thing must be on the unit circle. Alright. Go ahead and go to number 11 here. Basically, we just want to find the missing point, right? The missing coordinate. Well, we know that our equation is x squared plus y squared equals 1. So let's go ahead and kind of plug those things in there, and then we can solve. And then we want to use the quadrant information. So we'll get more to that in a second. But we go ahead and just square that 1/3, becomes 1/9. Subtract 1/9 from both sides. We're trying to solve for x right now so that we can figure out what x is going to be. So we get x squared equals 8 over 9. We have to take the square root of both sides. So when we do that, we get x equals the square root of 8 over, and then the square root of 9 is plus or minus 3, because you can square minus 3 and it'll get you 9, and you can square positive 3 and it'll get you 9. So let's figure out if we're working with the positive or the negative of this whole thing here. So we have our quadrants, right? It told us that this thing is going to be in quadrant 2. So if it's in quadrant 2, and again, quadrant 2, right, all of the x values are negative and all the y values are positive. That makes sense, right? In this area, we go negative and positive, right? So if our answer, or it tells us that we're in quadrant 2, then, well, our x has to be negative, so we're going to use the negative version of this rather than the positive. Therefore, x equals negative square root of 8 over 3. Cool. Alright, number 15 here. Very, very similar to number 11. Pretty much the exact same. So I just kind of run through it quickly here. And so it's the exact same steps. We're just plugging it into that equation of the unit circle, x squared plus y squared equals 1. So we plug in 5 over 13 for x, and then we're just going through and solving. So 5 squared is 25, 13 squared is 169. So we'll have to subtract this over to the other side. 1 minus 25 over 169 is, I believe, what, 144 over 169? Okay. and it tells us that the y-coordinate is negative. Okay, so when we take this square root, we'll have plus or minus on each side, but it tells us right here that the y-coordinate is negative. It says that in the problem. Well, if the y-coordinate is negative, then we know that we have to choose the negative version of this, so the positive doesn't work. So that's why y equals negative 12 over 13. Okay. All right, number 21 here. Okay, so I'm just kind of drawing this diagram here that they have, and they give us that at that first little spot it's t equals pi over 4. Well, just from our knowledge of the unit circle, we know that this whole thing from one side of the x-axis to the other is pi. That's pi length around, okay? So then all of these little pieces here are a quarter of pi. So we do pi over 4, and then add another quarter to that, and we get pi over 2. And another quarter to that, and we get 3 pi over 4. And then we get to pi, and we're adding another quarter, and we get to 5 pi over 4. Add another quarter of pi, we get to 3 pi over 2, etc., right? So we're just adding a quarter pi every time we go around, okay? And that's all they wanted us to do, is just to figure out, you know, what would t be in all of those cases, okay? All right, so in the next one, we're going by pi over 6, right? We're going by a sixth of a pi, right? So every time we go around, that first one would be pi over 6, etc. All right, so remember the terminal point, they give us some t value, okay? They give us some t value, and then they say, okay, well, what's the terminal point going to be? Well, the terminal point is this stuff right here. So if they give you like t equals pi over 4, well then you go to pi over 4 on the unit circle, and we find out what is that. Well, I'd really encourage you to pull up a unit circle, you know, just Google one or whatever, and then you're able to see that when you go to pi over 4, when you go up pi over 4 length, you get to the point x equals radical 2 over 2, y equals radical 2 over 2. And you'll get kind of more familiar with the unit circle as you use it, but go ahead and look that up because it's really going to be helpful, and just kind of have that next to you so that you can reference your unit circle as we go through this stuff. Alright, so remember the terminal point is the actual point, and t is how far along you're going on the unit circle. Okay?